Hey, sixth graders, welcome to another video. Mr. Ronan here, of course. This video I'm going to go ahead and call Unit 1 Review Part 1. So these videos will cover the Unit 1 review packet that I passed out a few days ago in class, but since there are so many things to cover through that packet, I'm going to break this up into separate parts. So here is Part 1. And what's going to be covered in this video is four different things. So we're going to talk about what parallelograms are, how to find the area of parallelograms, how to find the area of triangles, and what are polygons, because that's going to be important as we start talking about polyhedras and how to find the surface area and volume of those. So it's going to be important to identify what polygons are. All right, so right off the bat here, we're going to start with what is a parallelogram. So parallelogram, first off, it has to have four traits. One of those traits is it must have four sides. So if we look at this shape right here, we have one side, two sides, three sides, four sides. What we'll also notice about those four sides is that they're all straight. So we're not going to have any curved lines or anything like that. They're going to be completely straight sides. So for example, a triangle couldn't be a parallelogram because a triangle only has three sides. We also know that the opposite sides of a parallelogram are parallel. We should be able to remember that because in the name parallelogram is the word parallel. So opposite sides are parallel, meaning if they were to extend and keep on going, if you follow my mouse, if it were to keep on going, they would never cross or they would never touch. So as we see the sides directly across from one another, or the sides that are opposite of each other, those are parallel. And a parallelogram also must have opposite sides which have the same measure. And we see that in this example right here, where this side, if you follow my mouse, just based on the eye test, is the exact same measure. The opposite sides have the same measurement. They're the same length. And we see that with both sets of opposite sides. So if it has these three traits, we know we're dealing with the parallelogram. So we're going to run through 5 different examples. We're going to have to decide which of these are parallelograms and which of these are not. And we have to be able to justify our reasoning and explain why something's a parallelogram as opposed to why it's not a parallelogram. So for figure A right here, we're going to go and we're going to bounce back to the 3 characteristics of a parallelogram that we listed on this page as a reference. So the first thing I'm going to look for, does the shape have 4 sides? So I'm going to look at figure A. See, 1, 2, 3, 4. All right, so it has 4 sides. So far, so good. We might have a parallelogram on our hands. We'll have to go back and check. Take a look. So it has 4 sides. Are the opposite sides parallel? When I look at the top side right here and the bottom side right here, I notice that if those sides were to extend, they would never cross. So the top and bottom sides are parallel. How about the left and the right? Well, if I drag my mouse over and if I were to extend that line, let me see if I can, whoops, never mind. So if I were to extend the mouse and extend these lines rather, I see that those lines would eventually touch. They would make contact with one another. So I can confidently say that this is not a parallelogram because the opposite sides are not parallel. One set of opposite sides are, but the others are not. So A would not qualify as a parallelogram. Now let's look to figure B right here. So I'm going to go back to my list of characteristics that a parallelogram must have. And first thing, 4 sides. Does figure B have 4 sides? Let's check. 1, 2, 3, 4. Yep, got 4 sides. So far, so good. Opposite sides are parallel. Let's take a look. Let's take a look at the top and the bottom. So as I'm glancing here at figure B, I notice that the sides across from each other, the top and the bottom, if those sides were to extend, they would never cross. So the top and the bottom sides are parallel to one another. Let's try the left and the right one because with figure A, we had some issues with the left and the right sides. Those ones eventually crossed. Let's see if B is a little different. So if I were to extend these lines, it looks like these ones are parallel. So I'm going to go ahead and say, so far, so good. It has 4 sides. The opposite sides are parallel. Do the opposite sides have the same measure? So for this, I didn't give you guys measurements for this one, but if we just use our eyes, based on the eye test, it looks like the opposite sides are the same length. So this figure does qualify as a parallelogram. So B is in fact a parallelogram. With C, I remember this off the top of my head. Does this have four sides? 1, 2, 3, 4. So far, so good. Are the opposite sides parallel? Looks like it. Top and bottom, if they were to extend, they would never cross. The left side and the right side, if these lines were to extend and keep going up and down, they would never cross. And are the opposite sides the same measure? Let's see, the side length of the top part of this shape has 1, 2, 3 boxes. So it's three units long right here. On the bottom, it's also 1, 2, 3 units long. So the top and bottom have the same measure. Let's take a look at the left side. 1, 2, 3, 4 boxes. Let's take a look at the side directly across from it. 1, 2, 3, 4. So it does look like the opposite sides of that shape have the same measure. Therefore, C is also a parallelogram. So far we're just left with B and C as parallelograms. Shape D, the first thing on our list is 4 sides. Let's take a look. 1, 2, 3, 4, 5. So D is out. It doesn't have 4 sides. It has 5 sides. Can't be a parallelogram. I'm not going to waste our time and go through these other two traits or characteristics because it has too many sides to begin with. So it doesn't qualify. It doesn't cut it. All right. So figure E. Again, I'm looking for the amount of sides this shape has. Our goal is to have 4. If it has 4, we're on track and we're looking good, but this is a triangle. 1, 2, 3 sides. Can't be a parallelogram. Doesn't have enough sides. So B and C are the only parallelograms in this set. So now we know what parallelograms are. It's important for us to know how to find the area of parallelograms. Remember in class we talked about the formula about how to find the area of a parallelogram. In order to find that, we multiply our base by our height. So in this shape, right here, as we have a parallelogram or a rectangle, I notice that our base is 3 and our height is 4. This shape is 4 units tall. So I multiply 3 by 4 and I get 12 units squared. Remember, anytime we're finding area of a shape, we're going to be using square units. Let's not be confused because remember when we find volume, we're going to be using units cubed. So it's a bit different, but we'll get into that in part 2 of our Unit 1 review. And again, just to prove to you that if we multiply our base and our height together, we'll get our area. I'm saying a lot. Someone mentioned that in my last video that I've been saying a lot. I'm trying my best not to use that word, so I don't want to see any more comments accusing me of using the word too often. All right, anyways, 3 times 4, 3 is our base, 4 is our height. That gives us 12 units squared. If you don't believe me that 12 is our area, go ahead and count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you go. So we'll always multiply our base by our height. And what some people I noticed have been doing too is they'll like to add the base and the height. So they'll say our base is 3 and our height is 4, so we'll do 3 plus 4 and our area is 7. That is not how we're going to find area, okay? We have to multiply those numbers. It's an honest mistake, but we're going to have to multiply our base and our height. So these are also straight off your review guide that I passed out to you guys on Thursday and we went over in class on Friday. With this shape, with figure A, I remember that in order to find the area of this parallelogram, we have to multiply our base times our height. And remember, the trick we talked about in class was we always have to find that right angle. If we find that right angle, we're in luck because whatever sides or whatever measurements touch that right angle, whatever makes contact with that right angle, those are going to be the 2 numbers that we multiply. So right off the bat, I find our right angle right here. In the 2 lines that touch it, that touch that right angle, is the line called 4 centimeters. Notice if I bring my mouse all the way down following that dotted line, it's going to touch that right angle. So 4 centimeters. And what else makes contact with that right angle? Looks like the side called 9 centimeters. So 9 will be our base, 4 is our height. This shape is 4 centimeters tall. So we're going to multiply 9 by 4, and that'll give us 36 centimeters squared. Remember, we're finding area, so we're squaring our units. For figure B, again, I remember we're looking at a parallelogram. So the formula to find the area of that parallelogram is area equals base times height. We need to find our base. We need to find our height. A quick way, like I just mentioned with figure A, is just find out where that right angle is and multiply the two numbers that are making contact with that right angle. So I noticed that if I move my mouse on this side where it says 5 centimeters, if I bring my mouse down that line, I realize that at no point as I was dragging my mouse down that side called 5 centimeters, it made no contact with that right angle. So I'm not going to do anything with that 5 centimeters. It had nothing to do with that right angle. But I do notice that this dotted line is coming off that right angle. And that dotted line is called 4 centimeters. So I know I'm going to be using 4 centimeters in my equation. Another measurement that touches that right angle is called 5 centimeters. Okay, so our base will be 5 centimeters. Our height will be 4 centimeters. And we're going to multiply those two numbers together. So 5 times 4 will give us 20. And since we're finding the area of the shape, we're going to square our unit. So it's going to be 20 centimeters squared. All right. So after that, after finding the area of parallelograms, the next transition point will be finding the area of triangles. What I notice with a lot of us is we forget to divide by 2 when we're dealing with triangles. We treat every problem, or rather every shape, as if it's a parallelogram, and sometimes we'll just do base times height, and we'll call it, and we'll leave it at that. We forget to struggle with my words here. Bear with me. When we have a triangle, we forget divide by 2, and we end up with the wrong answer, or rather the incorrect measurement of area. So before we do anything, we have to identify what shape we have and how we're going to attack it, how we're going to find its area. So right off the bat, I'm looking at this this shape right here, and I see that it's a triangle. So I can't just do base times height, because that's our formula to find area of parallelograms. It's not our formula to find the area of triangles. In order to find the area of triangles, we multiply our base and our height, and then we divide by 2. Okay, that's incredibly important. If we don't divide by 2, if we forget to do that, we will not get the correct answer. So with this shape right here, I notice that our base is 1, 2, 3, 4, 5, 6 units. So our base is 6, and our height, so something that goes straight up from the base, right here, I guess. So 1, 2, 3, 4 units. So our base is 6, our height is 4. We're going to multiply those two numbers together and then divide by 2. And that's because two triangles can come together, two identical triangles can come together to form a parallelogram, which is why we'll end up dividing by 2. So we end up with 6 times 4 divided by 2. That'll give us 24 divided by 2. 6 times 4 is 24. And once we divide 24 by 2, we end up with 12 units squared. 12 units squared. Awesome. I guess we already did A on that last slide. So we're going to go ahead and we're going to focus on B right here. And remember, I'm looking at this shape and I see a triangle. I don't see a parallelogram, so we're going to have to attack this with a different formula. In order to find the area of that triangle, we have to do base times height and then divide that by 2. So our base of this shape, we're going to go from point to point, okay, or vertice to vertice. 1, 2, 3, 4. Okay, so our base is 4. And now in order to find our height, we have to figure out how to get from this base right here to the top of this triangle right up here. So I could go ahead and I can make an imaginary line. If you follow my mouse, I'm going to make an imaginary line to about right here. And that works out perfectly because now I can just go straight up from that point right here to the top of the triangle. Now I jump, and I'm going to count as I jump up. So 1, 2, 3. So our base was 4 units, and our height was 3 units. Rather, this triangle is 3 units tall. So I'm going to multiply 4 by 3, which will give me 12, and I'm going to divide that by 2, since we're dealing with a triangle, and that'll give me 6 units squared. Awesome. And then the last part of this video, we're going to talk about what polygons are. So a polygon has to follow all of these traits, has to have all of these things. If it doesn't have one of these 4 bullet points, then it does not qualify as a polygon. So first thing, a polygon is a 2-dimensional shape. Can't be 3-dimensional. A cube is not a polygon. A triangular prism is not a polygon. A rectangular pyramid is not a polygon. Those are 3-dimensional shapes. A polygon has to be a 2-dimensional shape. Okay, so like a square, or a triangle, or a rectangle, or a pentagon. That would be a polygon. It must have 3 or more sides. So basically anything like a triangle would qualify as a polygon. A polygon could have a billion sides. A polygon could have 3 sides. Okay, so as long as there are at least 3 sides, it can qualify as a polygon. All sides are straight. Okay, so we can't have any curved lines like right here. Look at this little twirly thing. Those are not straight lines, those are curved lines. Okay, so we need straight lines like we have in all of these examples. All these lines are straight. And it must be a closed shape. That means nothing can get inside the shape if it wanted to. So my mouse, for example, let's pretend that it can't go past any of these solid lines. There's no way for my mouse to get inside that shape or to pass through that solid line. Whereas over here under the non-polygon section, my mouse can easily sneak inside this shape, okay? Or it can easily sneak into this shape right here. So these are examples of non-polygons, these are examples of polygons. So we have to follow these 4 characteristics in order for something to be a polygon. So I'm going to go ahead and I'm going to go through these 6 examples and try to decide whether they would qualify as a polygon or not. So I'm going to go back to my list of characteristics. A polygon must be a 2-dimensional shape. This looks 2-dimensional, okay? I only see 1 face on this shape. I don't see 2 faces, I don't see 3 faces. Remember a cube, for example, right here on F. This would be a cube. It's 3-dimensional. There are multiple faces to this shape. So F cannot be a polygon because it's not 2-dimensional. This would be a polyhedra because it's 3-dimensional. So A is 2-dimensional, and I need to see, does it have 3 or more sides? Let me look. 1, 2, 3, 4, 5, 6, 7. 7 sides. So it has 3 or more sides. So far, so good. All sides are straight. There are no curves. So look at A, I notice, man, these all look like straight lines to me. So 3 down, 1 more to go. Is it a closed shape? Can something enter into this shape if it wanted to? Well, my mouse is having a hard time getting inside that arrow, getting inside that shape. So I'm going to go ahead and say this A right here, figure A, is a closed shape. And since it met all 4 of these bullet points, it passed the test. So A is, in fact, a polygon. Moving on to figure B. Again, we're looking for something that's a 2-dimensional shape. This looks 2-dimensional. Okay, I only see 1 face. It's not 3D like this cube over here. There's only 1 face. So we have a 2-dimensional figure. 3 or more sides. 1, 2, 3. It has at least 3 sides. All sides are straight, no curves. I don't know if I follow this mouse. These are not straight sides. They're a little curved. So B is not a polygon. Even though it was 2-dimensional, had at least 3 sides, and it's also closed shape, meaning my mouse can't enter in here if it wanted to, or rather something else could enter into this box if it wanted to. Even though it met those 3 things, it has curved sides, so it is not a polygon. Sorry, B. Looking at shape C, we're looking for something that's 2-dimensional. Yeah, this is 2-dimensional. It's flat. It's not 3D, only has 1 face. three or more sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 is more than 3, or 10 is at least 3, so that works, that matches. All sides are straight, and there are no curves. Yeah, these are all straight lines. So far, so good. 3 down. Let's see if it works. Is it a closed shape? You know, my mouse is having a hard time getting inside that star. And I'd imagine other things having a hard time getting inside of this shape. So I'm going to go ahead and say that it is a closed shape, and that would make C a polygon as well. D, I'm going to kind of fly through here. I noticed something immediately wrong with figure D. My mouse has an easy entrance into that shape. Get right in. So D is not a closed shape. It has 3 sides. The sides are straight. It's 2-dimensional, but it has an opening. It's not a closed shape. It's not a polygon. With E, we have a heart. It's 2-dimensional, but I noticed right off the bat that the lines are curved. They're not straight lines, so E does not qualify as a polygon. And F. Remember, I'm looking for a 2-dimensional shape. A cube is not 2-dimensional, it's 3-dimensional. As I just looking off this picture, I see 1 face, 2 faces, 3 faces, and we know cubes have 6 faces, which would make them 3-dimensional. So F does not qualify as a polygon. So we're only the only polygons in this set are figures A and figures C. This is going to be really important to remember because as we get into polyhedras, polyhedras are made up of polygons. Okay, the faces of polyhedras are polygons. So in order to identify what polyhedras are, we have to know what polygons are. Okay, so we'll talk more about that in part 2 of our Unit 1 review. That should be it for this video. Hopefully it was helpful. Again, let me know any questions you have in class, and I will try to have part 2 up by tomorrow, and then we can talk about it in class if you have any questions. Awesome. Thank you for watching this video. Have a good night.